Welcome to Math with Mrs. Bibb. Today we will be solving absolute value inequalities. When you look at these two examples, for real number a, the inequality, the absolute value of x is less than a, means it's the distance between x and 0 is less than a. So I hope that after watching the previous video for compound inequalities that you are able to look at this and say, okay, when you have absolute value and you have less than or equal to, then this is an and problem. And then when you look at the next one, looking at the graph itself, you can see that that's an or. When you have absolute value and a greater than or equal to symbol, then that's an or problem. This is very, very important to know. When you have absolute value, so when you have absolute value and you have less than or equal to, that's an and problem. If you have greater than or equal to, that's an or problem. I did not give you a sheet for this set of notes. If you will please make sure to copy down everything that you see. Since I did not give you a notes guide, please make sure that you write down everything you see and everything that I write. We are going to solve each of these. Before you can decide if you have an and or an or inequality, you have to make sure your absolute value is alone. And fortunately for all of ours, if you look at this, my absolute value is alone here, it's alone here, it is alone here, and it is alone here. So I will go over some of those examples where your absolute value is not alone. But when it's alone, you can decide what your inequality or what your conjunction is. So let's talk about that. The conjunction for this first one underneath example 1 is an and because of that less than symbol. The conjunction for the second one is or. For the third one is and. For the last one is or. Remember, less than or equal to, that's and. Greater than or equal to, that's or, when you have absolute value. Now, let's solve each of these. So I'm going to solve this one. M plus 5, you take away the absolute value just like we did when we were solving equations. M plus 5 is less than 3 and M plus 5 is greater than negative 3. And I'm going to solve both of those. I'm going to subtract 5. M is less than negative 2 and M subtract 5. M is greater than negative 8. So you can graph on 3 different number lines if you want, or you can think about it. Less than negative 2, greater than negative 8 would intersect between negative 2 and negative 8. Negative 8, negative 2, and I'm going to shade in red between negative 2 and 8. So that's what my graph would look like. And then I'm going to write that in interval notation. Reading that number line from left to right, it starts being shaded at negative 8 and it stops at negative 2. So that's my answer to the first example underneath example 1. Now for the second example, I'm going to do 2m minus 9 is greater than 13, or 2m minus 9 is less than negative 13. I'm going to add 9. So 2m is greater than 22. Divide by 2. M is greater than 11. Or, add 9. 2m is less than negative 4. Divide by 2. M is less than negative 2. So thinking about this graph, M is greater than 11 or M is less than negative 2, those two would go in opposite directions. Greater than 11, less than negative 2. Both open circles, and then write that in interval notation. It starts being shaded red, that number line, white number line at negative infinity. It stops at negative 2, parenthesis, union that starts being shaded red at 11 and stops at positive infinity. And that would be my answer to the second example underneath example 1. Now let's do the next one. It's an AND problem. I'm going to write my two inequality problems. X minus 1 divided by 2 is less than or equal to 1, and x minus 1 divided by 2 is greater than or equal to negative 1. Whoa. Oops. Okay. I'm going to multiply both sides by 2 to begin solving. X minus 1 would be less than or equal to positive 2. Add 1. X would be less than or equal to 3. And multiply by positive 2. X minus 1 would be greater than or equal to negative 2. Add 1. X would be greater than or equal to negative 1. And let's think about what that graph would look like. Less than or equal to 3, greater than or equal to negative 1. So those would definitely intersect. Negative 1, solid circle. Positive 3, solid circle. And the shading would be in between. And it would be bracket negative 1 to 3. Reading that white number line from left to right. My last one is an OR. So I'm going to write my two problems. 2x minus 1 is greater than or equal to 3, or 2x minus 1 is less than or equal to negative 3. I'm going to add 1 to both sides. 2x is going to be greater than or equal to 4, or add 1. 2x is going to be less than or equal to negative 2. Divide by 2, x is greater than or equal to 2, or divide by 2, x is less than or equal to negative 1. On a number line, greater than or equal to 2, less than or equal to negative 1, yes, that is a normal OR. So greater than or equal to 2, equal to, I made it open, sorry, less than or equal to negative 1. And reading that number line from left to right, it's shaded from negative infinity to negative 1, union 2 to infinity. That's my final answer for the last example on example 1. And next, write the absolute value inequality for each graph below. Okay. I am going to, remember this is an and those are open circles, so I know I'm going to have less than. The number in the middle, what is the number in the middle here? 3. Oops, I did not mean to do that. So you take your two solutions, remember, and divide by 2. So 6 divided by 2 is 3. And it's x minus 3 is less than, and what's the distance? Let me write in red. The distance from the mean, because remember you put the mean there. The mean to each solution, it's 1 unit. So x, absolute value of x minus 3 is less than 1 is the answer to that one. Okay, so for this next one, absolute value, I know it's an OR. It's greater than or equal to because those are colored in. And then I'm going to take those two solutions, negative 3 and negative 1, add them together and divide by 2. So negative 4 divided by 2 is negative 2. So I'm going to have plus 2 here. So x plus 2. And then what's the distance those are from the mean? Those are both 1 unit from the mean. Okay, let's look at the last one. It is an OR, and I have open circles, so it's going to be greater than absolute value of x, and let's see, negative 10 plus negative 2 divided by 2, negative 12 divided by 2, so negative 6. So this is going to be plus 6. Absolute value of x plus 6, and let me change colors. So if I am at negative 6, How far are those from the mean? 1, 2, 3, 4, 4 units here. 1, 2, 3, 4, 4 units here. So greater than 4 goes there. All right, and I want to add one more example. We'll call it example 3. We've got the absolute value of x plus 1 is greater than negative 4, and the absolute value of x plus 1 is less than negative 4. Only one of those, the answer is no solution. I want you to think about it. Which one of those would the answer be no solution? Positive numbers, these are positive numbers, greater than negative numbers. That's always true. So this one is infinitely many solutions. You do not have to solve it. This would be a special one that's shaded, strangely, not shaded like an or. So this one would be infinitely many solutions. When are positive numbers less than negative numbers? Never. So this is the only one that's no solution. I do not expect you to work out absolute value with negatives because of those two facts there. And that's all I have today. I hope you have a wonderful day.